Goedemorgen, zo op dit vroege uur, tenminste voor mij wel. Mijn naam is Quinten Laureijs. Ik werk als een pre-sales engineer bij Red Hat. Er staat daaronder wel Solutions Architect, dat is eigenlijk de officiële naam. Wat ik eigenlijk in mijn dagelijks werk doe, is dat ik klanten help bij het kiezen van een oplossing, in dit geval dan een Red Hat oplossing, maar natuurlijk ook verder nadenkend met open source en dat soort zaken. Dus dat zijn eigenlijk een beetje mijn taken. Vandaag gaan we het hebben over Mobicents, oftewel het JBoss Communications Platform. Het JBoss Communications Platform is eigenlijk een stabiele subset van Mobicents. We gaan het daar vandaag over hebben. Als jullie vragen hebben, steek gewoon even je hand op. Ik kom direct naar je toe. Mag je het zeggen in je microfoon? Dan kan iedereen het horen. En dan zal ik proberen de vraag te beantwoorden. Yes? Goed. Nou heb ik de hele presentatie in het Engels. Ik hoop niet dat dat echt een probleem is. Een vraag.
Oh nee, ik wil een vraag of het in het Engels komt.
Ja, is de behoefte aan om het in het Engels te doen? Ik schakel zo over.
Ik weet dat het Engels vragen, volgens mij misschien mensen bij
Maybe.
Does anyone want this presentation in English? They should raise their hands. That's sort of, okay.
Sorry.
No, it's no problem, it's no problem, I do it all the time, no problem. Good. Well, thank God the slides are in English.
Okay, yeah. Does anyone not want the presentation in English? That's normally...
That's very diplomatic. Okay, good, then we continue in English, no problem. First of all, communications platform, it's of course a very broad thing, it's a broad concept. It consists of many different components, software, hardware, applications. But the basic thing of a communications platform is the integration of voice, video and data to deliver that to the customer at all times. Most important thing, the term, which is very nice, convergence. Deliver any kind of content to any device, because that's more or less the direction where we are basically heading. Okay, Red Hat and Mobicents. Mobicents is a open source project founded by Evelyn Ivanov. Evelyn Ivanov is still the core developer and the project admin of Mobicents, but what Red Hat actually did is acquire Mobicents. It's not that we bought the project, but we hired the core developers of this project. That's what we usually do. Mobicents will still exist. You have to see it as the division between Red Hat Enterprise Linux and Fedora. Fedora is still out there, it's free, it's open source, it has the latest stuff in it, so to say. Mobicents, it's the same thing. Mobicents.org still has the latest stuff in there, but JBoss Communications Platform is a stable subset of that, what is good in Mobicents. With a stable subset, Red Hat can offer stability for enterprise customers that want support on that platform. We guarantee them 5 to 7 years support on this platform. We did this in May this year, so it's all really fresh. We even are in the process of developing a real actual product, so to say, but we're getting there. Also, by hiring developers, that's actually Red Hat's way of contributing to open source. Because when it all comes down, Red Hat is just another company. But we want to stay close to the open source and contribute to that as well. On the base of Mobicents, we have the so-called JSLEE concept, so to say. JSLEE is the Java Service Logic Execution Environment. This standard already exists. Was originally created by Sun Microsystems, and what Mobicents actually did was to create a whole new implementation of the JSLEE concept, so to say. It is based on JBoss techniques, of course, the JMix microkernel and related services. It's designed for scalability and availability by using techniques like GNDI and things like that, in order for different instances of Mobicents to run clustered, for instance, and auto-discovery, things like that. Of course, we'll see later on, I will show you some pictures on how it's built up. You can see that it's in a very modular form. You can put things in, put things out. It's very easy. Of course, you have to keep the core, which is JSLEE business logic, so to say. And eventually it works through resource adapters. Resource adapters are the thing that Mobicents interacts with, so to say, the outside world. This is a nice sentence. High performance core engine for service delivery platforms. Service delivery platforms are also a very broad and general concept, but it's a complete solution to deliver an application to, in this case, then mobile users. Mobicents also consists of service building blocks. This is what I mean by building it in a modular way. Service building blocks do things like billing, accounting, call control, really things like that. These are building blocks that are, like Java classes, put into the entire service, so to say. And of course, resource adapters. We have, of course, SIP, Session Initiation Protocol, as a resource adapter. Asterisk, you're familiar with Asterisk? Software PBX, open source. We have a resource adapter for that, so it can interact with Asterisk server. And of course, it talks Google Talk, XMPP. So this is basically what it looks like. We have, in the yellow part, we have, so to say, the application server, basically running all in one virtual machine. The Red Hat offering, entire product, so to say, will also embed a JBoss application server. So in this way, you can also use the connection between, so to say, the Mobicents part and the JBoss application server, and all the possibilities that are in there, in the application server, to connect to databases, to do clustering, high availability, things like that. So it's all in actually one package. And in the blue oval, you will see different kind of resource adapters that interact with the outside world, either through protocols or standards, APIs, things like that. And on the, for you guys on the right side, you see the management interfaces that are possible, JMX, web, Simple Network Management Protocol, and the command line. So Mobicents is actually the first open source implementation of JSLEE. Performance, I must say, is of course good, because telco providers and telco standards require good throughput and guaranteed delivery of services. It's not possible to have a telephone call waiting on another process on the server, things like that. You don't want that. You want real-time delivery. This is also still in development within Red Hat. Are we going to bundle this with the, so to say, normal Red Hat Enterprise Linux, or do we do something like a real-time Linux? Real-time having specification, or being compliant to specifications that guarantee a certain bandwidth. So that's what we're trying to find out still. The last sentence, the last bullet point, is a nice one. The triple play game. I've put that in bold. The triple play game is actually what this is. Triple play, what we then mean is it's an interaction between individual developers, a service provider like Red Hat is, and companies. Companies that use this product will eventually also start to develop on this product, and its development from this company are then fed back into the open source community. In this way you have like a triple play, so we call it, that also companies contribute to development of open source projects, in this case then Mobicents. This also goes for Linux. I see it every day. There are big companies that are using Linux. They're inventing patches, they're having developers working on Linux, and eventually all those patches, additional software, get into the upstream kernel, for instance. So that works really nice, this triple play. So, what does the community look like? Basically, there's one core project for the JSLEE implementation, and there are some sub-projects that comprise actually the resource adapters, which are the key functionality to the Mobicents server, so to say. Third most active forum on Java.net. I'm not quite sure about all the statistics. About 2,000 downloads a month. And you see the contributors to this project are mostly business driven. So we have Portugal, Portugal Telecom, Vodafone, Italy is also heavily contributing. Also the NEPs are working with us. Everybody knows what a NEP is. Network Equipment Provider. Oh, there you go. And of course, individual users, companies that use the software. The 5 core contributors are, and 3 of them are Red Hat employees. So that's, again, our contribution to open source and keeping it going. So this is eventually what it looks like. You see below, well, let me explain first. This thing here, it actually says where Red Hat steps in. So everything that is read around is something that Red Hat does. But it starts with commodity off-the-shelf hardware, blade service, all those kind of things, network products. On top of that, you have either RHEL, so Red Hat Enterprise Linux, or a carrier grade form of that. You see also there a little red box on the left. It says OpenAIS, which is our clustering product, so to say, to cluster different physical machines together to deliver a service for everything that comes actually on top of that. So then we have on top of that the JBoss communications platform. We see it now as a complete entity, but I will show a little bit more detail in the next slide. And on top of that, for instance, the JBoss Enterprise Portal platform. In this way, it's possible to have an interface to all the services that are delivered by the communications platform. So this is actually more or less a high-level 10,000 feet overview into the JBoss communications platform. You see, of course, the network resource adapters, which have to do, of course, with all the functionality that should be possible for the server to function. So you see SIP, the Session Initiation Protocol, which establishes telco sections, so to say. XMPP, that's the extended messaging and presence protocol, like how to say Jabber, MSN, things like that. It's all about integration, of course. Diameter is the successor of Radius. Of course, Radius is, with the circles and things. Diameter is an extension to that, has to do with authentication. authorization and accounting. Parlay is a concept, a UML concept, that actually describes how APIs should be in the telco industry. And of course, SMPP, the short message platform protocol, media, and a lot of more things. Most important thing is on the upper left side, the service logic execution environment. That's basically where it all happens. This is business logic that says, well, here you do this function, here you do that function, all is handled in that. And the enterprise server, the JBoss enterprise platform, so to say, the application server, which basically runs in the same VM practically, then is able to communicate with the service logic execution environment, so you can have interaction between those. Okay, I'm going to show a little example of how it all works, basically. We take the example of voicemail servers. Voicemail servers has an operator which does user provisioning. Basically, the user pays to use his phone on that specific network. The operator then provisions the server, and the user is allowed to do some calling. That's what it all basically comes down to. So you see here, the operator connects mostly through web interface, adds a profile to the subscriber, enters its name, all data, which numbers to use, and that's basically just one step that he does. Then we have the call sequence, and I'm wondering if it's all tiny little letters. Can you read that? Yeah, you're more in the front than the people in the back, so to say. So you see there are actually two pieces of logic working in conjunction here. The user initiates the call, so to say, and registers via the SIP protocol and makes sure that everything is in good order as defined by the profile that he has gotten. So once that is done, the authentication, so to say, it will establish a session to the RTP, which is the real-time transaction service, so to say. So delivering, of course, real-time communications, if you will. Once that is done, it will get eventually an acknowledge from the user, and then the business logic starts to work here. You see, it will get a voicemail greeting saying somebody is not online. This is checked by the XMPP protocol, for instance. Well, this user is not online, I should give a voicemail message. He gets the greeting and he can record the message. Then the transaction is actually closed, so to say, and the call is terminated. It's a basic setup, but the most important thing are the subserver and the RTP server interacting with each other throughout the whole stack. So here you see, again, those two things which are important. You have the service building blocks. The service building blocks can interact and will interact with both layers, so to say. This business logic is designed to do what it must do on both layers. So checking if a user is valid, checking if a session can be established, sending out the voicemail greeting message, all those kind of things are done through these protocols, but one service building block has to access both of them, which is inherent in the architecture of Mobicents. So the milestones so far, I still believe we are we are the first. I'm not sure if we're the only one that are JSLEE certified. and it's completely free and open source software. Go to mobicents.org, download the software and start playing with it. It's just that simple. Also, we adhere to standards, of course. JSLEE 1.2, it's completely certified. Since then, 5 public revisions already happened since the certification of that. I believe it was in 2005, already some time ago. The entire product, the JBoss communications platform, will also, of course, include a application server. And you see a complete list, or not, yeah, it's a complete list of resource adapters. So you have the SIP protocol, Google Talk, Asterisk, INAP, Parlay, GCA, Diameter, the whole thing is in there. Very important is, of course, the high availability to our customers. Customers that require high availability can get it with this platform. All the functionality is there. And the most beautiful thing, what I personally think, is it's all open source. Everybody can look at the code, contribute, use it, and it doesn't cost a penny. It's great. For performance, having a real-time delivery platform also guarantees a certain level, a quality of service, as we call it. You see here the performance, which are in calls per second, and it seems to me that it's pretty neat to do that. Most telco standards require at least 50 calls per second, so to say. Last but not least, there's also a development tool being made, the JSLEE. Nice name. This is, of course, sort of, it's based on Eclipse, of course, especially created for the JSLEE standard. So you also have the tool to create any application using all those different components, the resource adapters, the business logic that's inherent to the server. You can use that in your development program, so your IDE, and start developing whatever you like to do. Some examples. I'm not sure if I have an internet connection here, so I can't really show it to you. But there are already some production deployments. I will show you some examples of websites. They're quite colorful, so to say. But you see also Vodafone, the club from Vodafone, for those who are with Vodafone, already uses Mobicents or parts of Mobicents to deliver services to their customers. The last bullet point, D2C, is typically a service that is delivered to customers that contain mainly video. But it's a nice way to see that this kind of things are all being integrated in mobile devices, and that open source can deliver a platform like that. It's not all Linux and BSD and things like that. No, we go a step further. And in this case, you see that businesses, real companies, are working in an open source way. So again, this triple play, open source developers can benefit from the effort that the companies actually put in building open source software. And to be honest, a lot of big companies are contributing also to the Linux kernel and things like that. So it's already there. It's not an exception or anything. It's already being done. Then you get websites like this. It's probably an Italian dating club. So you can send an SMS and you get in contact with this beautiful Italian lady. In Portugal, it's, I believe, sort of social networking site. Basically looks like this and delivers content to mobile devices. So, where are we going then from this point? This is the roadmap. The green colors is stuff that is stable and proven. The yellow stuff is in beta, and this is pretty old roadmap, as in about 5 months ago. The asterisk resource adapter is basically already there. And you see also CSCF, HSS, Media RF, which is still, those things are vital, of course, but are being developed upon. HSS, for instance, is the home service server for use, where all their profiles are stored, their data, how much did they call, what are they going to use, things like that. These things are currently being developed. What is mostly the use case these days is that companies create, for instance, an HSS by themselves. Later on, this will all be integrated into a complete package which can be used and deployed by companies. Certification for the JSLEE 1.1 is underway, and we're basically getting there. Furthermore, Java 6 yet not supported, but will be soon. Service building blocks are like EJBs, Enterprise Java Beans, but with some additional properties. And that, of course, has to do with specifications of the telco industry that require a guaranteed delivery and functioning of these products. This is already in an advanced stage, and we'll get there. Resource adapters, there's a complete description of an architecture of a resource adapter, how this one should look like. So all these things, all these components are open standards and are described open standards. The APIs are also described. In this way, all kind of parties that want to use this software or develop this software know what they're up against. It's also the thing that Red Hat says. Red Hat says use open standards. I read last week that Microsoft is pointing their patent guns at us. To be honest, we're not scared. We're really not. We just want to see, well, if there is an infringement, well, show us and we'll fix it. Absolutely no problem. Of course, profile facility. See there distributed cache. It's also a feature of which is inherent to Mobicents. This distributed cache makes it possible for servers to drop out and keep sessions still. Very advanced technique. And of course, a tracing facility which has to be SOX compliant and things like that in order to trace. Good. Questions?
Nederlands of Engels?
English, I think.
Can you tell a little bit more about how you achieve high availability? Which products are being used and which products can be used?
Right. The products that we use for that are JMDI, the Java naming and device interface. Also, JBoss clustering is also there. Auto discovery of different instances of Mobicents that automatically see each other over a network, which is of course transparent to Java. JBoss clustering is also one of the techniques which is being used to ensure high availability. In combination with also with Red Hat, you can also achieve high availability, so to say, on a lower level, doing cluster mirroring, high availability failover techniques like that. So it's actually on both levels. It's on the Java level, and it's also on the operating system level. And of course, below that you have the hardware level, which should be supported, of course, by the operating system, but that's basically our job with the vendors. More questions? You told me you got have questions.
So I wonder, is this only useful for large telecom companies, or could it also be useful for a small website? Could I do some nice things with it?
If you like, yes. But this thing is, at this moment in time, it's pretty complicated. I mean, what I show is really high level, but it's really, it's of course possible if you're knowledgeable enough to use it for your own smaller websites. Yes, sure, it's no problem. It can run on your laptop. That's absolutely not an issue. It's all a matter of what you do with it. I mean, you have to have developers, people that know about Mobicents and know how to work with it, develop on it, develop an application on it. Because you can go to mobicents.org, download it, and then what? You still don't have anything. You need to develop an application. You need to have connections to a telco provider. I mean, you have to use their network. So it requires a lot of organization. So that's also the reason why actually only big companies are interested in that. But maybe in the future, and I don't think it's really unlikely, it's possible to have this as your own little server, maybe even in a phone, in order to connect to different telco providers, network providers, and use this technique to be around and to use all the services that are in there. So there's a lot of possibilities also for the individual user. More questions?
Then I would like to thank you for your talk.
Okay, thank you. Zoveel presentaties voor iedereen. It's all about what, well, it's a market. There's a question, there's need for stuff, and some companies seem to deliver that. This is the one in Portugal, Psychopathy. Let's see, other links from I text you. That's that one. D2C. So you see here the video mobile specialist, as it is called, and they can deliver then content, video to especially these Nokia devices with the webcam. You know, you can see each other while talking. I think it's fun. Sometimes you want to see a color, sometimes you don't. So there's a lot of stuff possible, and these are actual production implementations. So it is already proven to work. Only the whole thing still needs a lot of stuff to be worked on. But you see, it's just another open source solution that really, really works.